When it comes to footprinting wireless networks, just listening to the air and seeing what's out there, what we could connect to, we have two different ways to do this. We have passive methods and active methods. With passive methods, we're simply going to listen to the air. So we put our wireless network interface card into monitor mode, and we start listening for those wireless beacons. And we can gather a lot of information from just beacons. And then we have active methods, where we're going to actually probe with an empty SSID to try to see what's out there. Several tools we can use for this. Most often you're going to see it done with software on a laptop with hopefully an external antenna that has some gain so that we can capture wireless networks that are a little bit further away. Some common tools used for finding these wireless networks, we have AeroDump NG. It's part of the AirCrack NG suite. We have this URL here to get more information about the AirCrack NG suite. This is built into Kali Linux, so you just, provided you have a wireless adapter that will work with Kali Linux, then you can run the AirCrack NG suite. Most of them will. The reason I mentioned that specific point, so let me go off on a little tangent here. So a lot of times you will see someone on a laptop running Kali in a virtual machine, like VirtualBox, VMware, whatever the case may be. And then they will use a purpose-built USB connected Wi-Fi adapter that is connected to the virtual machine that allows them to maintain wireless internet access from the laptop, and then the virtual machine is using this USB connected Wi-Fi adapter in order to run the AirCrack suite of tools. That's what I commonly do in order to run these tools. We also have MetaGeek Complete. This is a commercial offering that will analyze channels, display SSIDs, etc. We also have ViStumbler, VI Stumbler. It will provide you with SSIDs as well. It can take GPS latitude, longitude input. So you run the software, connect a GPS receiver to your laptop as well as the wireless interface, grabbing this information, and we can tie SSIDs to physical locations. Now, most of us are walking around with some sort of Wi-Fi enabled device in our pocket. We have this application NetSpot for both iOS and Android that will listen to the air and show you an interesting piece of information. The signal strength, that's the height, as well as the channel that the particular SSIDs are on. Wiggle is a service that's been around for a long time. It's crowdsourced war driving database. So you run this app on your phone. That information is passively listening in the background. That information is then uploaded to wiggle.net and plotted out on a map. Here we see San Francisco. So it will gather those SSIDs along with location gathered from your phone and upload that information to Wiggle. When we are capturing this information, what sort of information can we glean from this data? We get names of networks, and most often you're going to see a name associated with a business name. If you have grocery store and you see grocery store SSID, it's a safe bet that that SSID belongs to that grocery store. We can learn encryption protocols, authentication methods as well. We can know if they are doing multiple APs on the same SSID and using that BSSID concept in order to distribute a single SSID across a wired network. The OmniPeak tool can be used to analyze wireless traffic, and what we're talking about here is actually capturing the Wi-Fi frames themselves. Not the data in the frame, but the frame which contains the data. So OmniPeak from Live Action is available to do that, and then off-the-shelf non-commercial, we have Wireshark. Wireshark can capture frames, show you 802.11. Here we see a bunch of beacon frames that are being captured by a wireless interface connected to Wireshark.